Hello everyone, welcome to section 5.1 where we're going to talk about ratios. So this module is on ratios and proportion and we'll begin by discussing ratios. So a ratio is a comparison of two quantities expressed as a quotient, right, or as a fraction. So is a comparison of two quantities expressed as, I'll say as a quotient. It's really a fraction, right? So, for example, the ratio 2:5 can be written really several different ways. So it can be written you could say just 2:5, right? That's one possible way of writing this. So 2:5, but that's equivalent to 2:5, so that means the ratio of 2:5, or as we just discussed, it can be written as a quotient, so I could say this is also 2/5, right? So that quotient is really just a fraction. So all of those are different ways of representing the ratio 2:5. So normally what we want to do is we want to write a ratio and then simplify, right? So to simplify, a ratio, you want to write it as a fraction and then simply simplify the fraction. So write it as a fraction, then simplify the fraction. Okay, so here are some examples. Let's say I want to write each ratio in simplest form. So if I'm given the ratio 9:12, then I'm going to write it as a fraction, right? As a quotient or as a fraction, so 9/12. But then, of course, we can simplify that, right? Because we know if 3 goes into 9, 3 goes into 12. Or if you want to think about this, we could rewrite this as 3 times 3 over 4 times 3. So I can take out a factor of 3/3. So this is going to be 3/4. So 9:12, that ratio can be simplified to 3/4. If I have the ratio 8:10, well, I can write it as a fraction. And then if I simplify this, right, we know 2 goes into 8 4 times, 2 goes into 10 5 times. So it simplifies to 4/5. What about this one? What if I have the ratio 25 to 1 1/4? Okay, so really this means 25 over 1 1/4. But we don't want to work with that number, the mixed number, as a mixed number. We want to rewrite it as an improper fraction. So I could write this as 25 over, and remember, if I convert 1 1/4 to an improper fraction, it's 4 times 1 plus 1, so that's 5/4, right? So this is 5/4. And then you can think of this as 25 over 1, right? So any whole number you can put over 1 to rewrite it as a fraction, divided by 5/4. But remember, to divide those, it's going to be 25 over 1 times the reciprocal. We have to flip the divisor, right? And then I can simplify a little bit here. 5 goes into 5 once. 5 goes into 25 5 times. So this is going to be 5 times 4, which is 20 over 1. So 25 to 1/4 simplifies to 20, right? Or you could say 20 over 1. You could also just write this as 20. But if we leave it as a ratio, it's really 20 to 1. Okay, those are all pure numbers, right? What if I have units attached? So let's say I want to simplify $40 to $25. Okay, so I put $40 over $25. Right? I form that quotient, that fraction. Notice here that the units of dollars are going to cancel, right? Think of it as dollars over dollars, that's gone. And then I can simplify this because 5 goes into both of them, right? 5 goes into 48 times, 5 goes into 25 5 times. If you forgot how to simplify, remember you could always find the prime factorization of each number. Let's just review that real quick. So if I factor 40 into a product of prime numbers, remember we draw the tree. I start with the 2, right? Remember the prime numbers are 2, 3, 5, 7, and so on. Does 2 go into 40? Yeah, it goes in 20 times. Does 2 go into 20? Yep, it goes in 10 times. Does 2 go into 10? Yeah, it goes in 5 times. And in 25, 2 doesn't go in evenly, 3 doesn't go in evenly, but 5 goes in 5 times, right? And then I stop because they're all prime numbers. So really 40 over 25 is the same as 2 times 2 times 2 times 5 over 5 times 5. And here we can easily see that the 5 over 5 cancels, right? So I can take out a factor of 5 over 5, and I'm left with 2 times 2 times 2, so 2 times 2 is 4, times 2 is 8 over 5, okay? But, so again, if you have to go back to basics, that's fine. If you can quickly see in your mind that, oh yeah, 5 goes into both of those, I can simplify to 8 fifths, that's fine as well, okay? But notice again that the units cancel in this case. Here's another example. Let's say I have the ratio 19 ounces to 51 ounces. So 19 ounces over, right, I can form the fraction over 51 ounces. Again, notice that the units, ounces, cancels, right? So this is really just 19 over 51. And that, it doesn't look like I can simplify that any further, right? 19 is a prime number, and if it doesn't go into 51 evenly, let's see, times 2 times 3. No, it doesn't look like it goes in evenly, so that's the best we can do. Okay, so that would be in simplest form, 19 over 51. And then I just want to note here about the units. So notice how the quantities are basically like. In other words, they have the same units. Right? So they're like quantities. They both represent, in this case, it's going to be a mass, right, in ounces. So therefore, we can drop the units. We can cancel the units. And then we just get a pure number, right? A pure fraction at the end. What if you want to find the ratio of two things where the units are not the same, right? So that's called something slightly different. It's called a rate. So let's talk about that a little bit. So a rate, I'll start a new page here. A rate is a ratio of unlike quantities. And by unlike quantities, I mean they have different units. So different physical units, right? They represent something different. So here's an example. Again, let's say we want to write the rate in simplest form. So write the rate in simplest form. Okay, in the first example, I'm given 42 gallons in 4 minutes. Okay, so that's my ratio, which is really a rate, right? Because it involves different units. So I formed a fraction, 42 gallons, I'll just abbreviate that as GAL, over 4 minutes. 4 and then MIN. And now I can simplify 42 over 4, right? It looks like 4 doesn't go into both, but 2 goes into both. So I could write this as 2 goes into 42, 21 times? So this is 21 gallons over 2 minutes. And that would be the answer. And notice here, because the units are different, we have to keep the units. I'll say must keep the units. Right, so that's all a rate is. It's simply a ratio, except you have different units, and you have to keep the units. Here's another example. 18 boxes of cookies for $45. Okay, so I formed the ratio, 18 boxes over $45. Now here it looks like I can simplify that, right? Because 9 goes into both of them, right? You can think of 18 as 2 times 9, and then 45 is going to be 5 times 9, so 9's cancel. So this is 2/5, but we have to keep the unit. So it's 2 boxes over $5, right? Because it's a rate now, so we have to keep those units. By the way, you could also write it the other way, right? If it said $45 for 18 boxes, then you would flip it, and it would be $5 per 2 boxes. Okay, here's another example. Let's say you're told 57 hours of work in 9 days. Okay, so I'm going to form the ratio, which is really going to be a rate because they have different units here. So it's 57 hours over 9 days. And then can I simplify? Yeah, it may not be obvious, but 3 goes into both of these, right? If we do the prime factorization, 2 definitely doesn't go in, right? Because 57 is not, even if I try 3, right? If we divide this, 57 divided by 3, this is 127, so it's 19 times. And then I stop because 19 is prime, and then 9 is 3 times 3. So this is really going to be 19 hours over 3 days. And that would be my rate. Okay, now sometimes we want to go further, right? We want to write a rate where the denominator is equal to 1, right? So we just have 1 and then whatever the unit is in the denominator. So what is that called? That's called a unit rate. Remember, unit sort of means like 1, right? So a unit rate, again, I'll go to a new page here. A unit rate is a rate in which the number in the denominator is 1. Okay, so how do we do that? Well, basically we have to divide out, right? So let's say we want to find, I'll do a few examples where we want to find the unit rate. So let's say we're given 192 meters in 6 seconds. Okay, so I write it as a ratio, right? 192, I can abbreviate meters as m over 6 seconds. But because I want to write it as a unit rate, I have to divide that, right? So I get an actual answer, and then remember, you can put that answer always over 1. So if we divide this out, I'll just do long division here. So 192 divided by 6. 6 goes into 19 3 times, right? 3 times 6 is 18. I subtract, bring down the next digit, 2. 6 goes into 12 twice, multiply, and my remainder is 0 in this case. So this is the same thing as 32 meters per 1 second, right? Because I can always put my answer over 1. So 192 divided by 6 is 32, but I can put it over 1. So it's 32 meters per 1 second. And then usually you don't even write the 1 there, right? So ultimately you would just say this is 32 meters per second, which implies 1 second in the denominator, right? So that would be a unit rate. By the way, you may notice here there's a little bit of physics, right? This ratio, this rate here, is the speed, right? It's a distance per time, meters per second. So really this is the speed, which is the rate. Okay, here's another example. 7 tanks of gas to cut 10 acres of lawn. Okay, so I want to write that as a unit rate. So first I write the ratio, 7 tanks, meaning of gas, over 10 acres. Okay, then we divide it out, right? So 7 divided by 10. Well, let me write it as a decimal, so I'm going to need a decimal point there and then some zeros. I guess just 1 0 in this case. And 10 goes into 77 times. The remainder is 0. So this is equal to 0.7 tanks. Let me write that better here. Tanks per 1 acre. Which again, you don't need to write the 1, you can just put acre. Okay, here's another example. 648 heartbeats in 9 minutes. Okay, so again, I start by forming the ratio. I'll just say beats, meaning heartbeats, over 9 minutes. But if I want the unit rate, I have to divide this, right? So 648 I'll do this on the side here, divided by 9. So what is this? 9 goes into 64, 7 times, right? So that'd be 63. Subtract, bring down the next digit, 8, and then 9 goes into 18 twice. So the remainder is 0. So this is the same thing as 72 beats per 1 minute. Or we could say 72 beats per minute, right? You don't have to write the 1 there. So really, what are we ending up with? The heart rate, right? The heart rate is 72 beats per minute. It's always per 1 minute. So it's really just a unit rate. Okay, now a related concept is something called a unit price. So that's the price of one item or 1 unit. So a unit price is the price of one item or in more general, just of 1 unit, whatever the unit may be. Okay, so let's do a couple of problems with this. So really, this is just a rate, right? A unit price is like a unit rate again. So let's say we want to find the unit price and we want to round to the nearest cent. Okay, so here's the information you're given. Let's say you take a college class and 4 credit hours cost $200. So 4 credit hours for $200. Okay, and I want to find the unit price, which is going to be the price, right, the amount in dollars per credit. So the ratio I want to form is I want in the numerator, I want the amount of money, right, over, and then the number of units, in this case, number of credits, that'll be in the denominator, 4 credits. So then if we simplify this, right, so basically divide again, so 200 divided by 4 is going to be what? This will be 5, 0, 0, and then 4 goes into 0. Don't forget the 0 there, right? So this is going to be $50 per 1 credit, right? Now I have a unit price, so it's per 1 credit because I divided it out. So $50 per credit. Okay, a few more examples here. 12 bars of soap for $5.40. Okay, we want to find the unit price. So I first formed a ratio, right? I put the cost, the total cost in the numerator, the number of units, 12 bars in the denominator, and then I want to write it as a unit rate, which is a unit price, by dividing it out. So if I divide this, let's say 12 goes into 54, 4 times? So that'll be 48. Subtract, that's 6, bring down the next digit, which is the 0, and then 12 goes into 65 times. So this is going to be $0.45 per bar. Okay, and of course, we know that there's 100 cents in $1, right? So I could convert this to cents if you want by multiplying. I could say, well, I have $0.45. If I multiply by 100 cents over $1. See how dollars will cancel, and it'll end up with cents. But what's 0.45 times 100? Remember, times 100, right, power of 10. I just moved the decimal place 2 places to the right, right? So this would be 45 cents. So another way of saying this, of writing this right here, it's 45 cents per bar of soap. Okay, here's one more with unit price. Let's say 60 minutes of internet access for $3. So again, I want the unit price, right? So I have to put the amount in the numerator, $3, and then the number of units, which is the amount of time, 60 minutes, in the denominator, because I want to ultimately end up with the price per minute, okay? So to do that, I need to divide this out, right? So I have 3 divided by 60. So I'm going to end up with a decimal, right? So I'm going to put the decimal point. Remember, if it's a whole number, it goes right at the end, to the right hand, to the right of the number. Then I'm going to add some zeros here. So then divide this. 60, does it go into 30? No, so I can put a 0 there, right? So this is 0. I subtract, bring down the next, so it's 30, bring down the next digit, 0. And then 60 goes into 300 5 times. And then the remainder is 0. So this is going to be $0.05 per minute. This is when they used to have like internet cafes and you had to pay, typically by the hour. So $3 for 60 minutes for 1 hour. So if you want the price per minute, then it's going to be $0.05 per minute. Or you could write this, remember, $0.05 is the same as 5 cents per minute. Okay, great. And then let's do a few questions from My Open Math from your homework. Okay, in this example, it says last week you worked 36 hours and earned $261. What is your hourly pay rate? Right, so we want a unit rate, right? We want the amount that you get paid in dollars per hour. So how do we do this? Well, let's form the ratio first, right? It's going to be $261 per 36 hours. And then to find the unit rate, I need to divide this. So if I divide 261 by 36, I'm probably going to need some decimal places there. So let me put a couple of zeros in there. So let's see. 36 doesn't go into 26, right? 36, does it go into 261? Yeah, probably, let's say maybe 7. Let's try 7 times. So this would be 7 times 6 is 42. 7 times 3 is 21 plus 4 is 25. Okay, yep, that works. So now I subtract. So this is going to be, I need to borrow, right? So it'll be 11 minus 2, which is 9. And I bring down the next digit, 0. 36, does it go into 90? Yeah, it goes in 2 times, right? So if I multiply 2 times 6 is 12, and then 2 times 3 is 6 plus 1 is 7. Subtract, so this is going to be 8 and then 1, right? I had to borrow here. And I bring down the next digit, which is a 0. And then 36 into 180, actually it turns out it goes in exactly 5 times, right? So 5 times 6 is 30. 5 times 3 is 15 plus 3 is 18. So it goes in exact, right? Remainder 0. So what we found is that the hourly rate, right, the unit rate is $7.25 per hour. So this is going to be $7.25. Okay. All right, and then let's do one more question. So this question says, find the unit price. If necessary, round your answer to the nearest cent. You would enter an answer like $0.49 per pound, the value like 0.49 in the first box, and the appropriate unit, they want the unit in the second box. Okay, so in this case, they're telling us 4 liters of whatever it is cost $0.89, right? 89 cents for 4 liters. So I first formed a ratio. So it's going to be $0.89 over 4 liters. And then to find the unit price, I need to divide, right? So if I divide this out, .89 divided by 4, right? I don't have to move the decimal point at all, so this is going to pop up right there. So 4 goes into 8 twice, so that's going to give me 8. I subtract, bring down the next digit, so it's a 9 here. 4 goes into 9 twice. It looks like I'm going to have to go further, right? If I want to round to the nearest cent, which is really the hundredths place when I'm in dollars, then I need to go at least one more spot here. So this is going to be 8, right? Then I subtract 1 and bring down the next digit, which is 0. 4 goes into 10 twice. Let me go just one more. So this is going to be 8. And subtract 2, bring down the next digit, which is this 0. 4 goes into 25 times. Okay. But again, if I'm going to round to the nearest cent, right? Remember, in dollars, the hundredths place is going to be near a cent. So if we look to the right, that's going to be, that's less than 5, the 2. So that's going to stay at 2. So the answer here is going to be $0.22 per liter. So in here, you would put in 0.22, and here you'd put in liter. They probably want just liter instead of liters because it's per 1 liter. So liter. And that would be it. All right, great. So that was an overview of ratios, rates, and unit prices, which are nothing more than unit rates, but it's a price per unit. Okay, the next topic I want to talk about, the next section, is proportion, solving proportions.